So if you have any questions, feel free to add them there or comments. That's cool. I've got that up and hopefully I'll see it as well. Anyhow, let's get started. My name is Chris Klug. I work as a software developer / architect / public speaker at a company called Active Solution in Stockholm. We do custom development in the Microsoft space for different clients. And I've been doing web development since '96 professionally. Or at least I got paid the first time, '96. I've been working professionally, hired at a company since 2000, so about 20-ish years now. It's giving me kind of a cool background of the C# stuff, because I was early enough to be there when they released .NET 1, and I've seen C# from going from nothing to where we are today, which is really cool. And I'm also very, very happy that I got to be there in the beginning, because C# is getting big and there's a lot of stuff to learn. And that's kind of where this talk came out of, because I've been around for a long time. I haven't spent too much time looking at the C# language as such. So I went down and I said, hey, I want to do a talk about the best new C# features. And the reason for going with the best is basically just that there's so much stuff in there, and not everything is really useful. And when I'm saying best, it's obviously best from my view. And there's a lot of performance stuff that's really cool in there, but I don't think most developers have the use for that. So I'm going to focus on the best features that I like. So that was the basics of my talk. And I said, hey, I'm going to do a top 3 best features. And no, actually, that sounds like a lightning talk. If I'm going to talk about 3 features for an hour, it's going to be really, really deep into something which is going to be quite boring. So I went, hey, how about the top 5? Top 5 best features would be really cool. I think that's enough for a talk. And then I started looking at the spec for what came out in C#6. And honestly, that's a bit terrifying. I ended up looking at the spec and going, oh no, I'm going to do 10. I need 10 best features, because there's so much stuff coming out in C# that I really need only 10, or rather I need 10. That's what I could get it down to. So here it is, my top 10 best new features in C# version 6 to 9. And as I said, they're all my best features, the things that I enjoy. So if you don't agree, too bad, not my problem. You decided to go and listen to me talk about my favorite features. So this is what you're going to get. But before we get started, there's some minor things I need to cover before we can actually go and look at the actual features. So we need to have a look at this chart here. So the default language versions for the different frameworks. So what C# versions you can use depends on what framework we're targeting. And also, there's a default version that you get when you start a project for that framework. So if you, for example, are doing .NET framework, like the old classic .NET framework, and you're on 4.7 or 4.8, 4.8 is the latest one, I think. Actually, you get all the .NET framework versions, but you should upgrade to 4.8. But if you're on .NET framework, you get C# 7.3. You don't get 8 and you don't get 9. And some of the 8 features and some of the 9 features will work on .NET Framework, but you get 7.3 out of the box. .NET Standard 1, 7.3, .NET Standard 2, 7.3, for quite obvious reasons, because .NET Standard 2 has the ability to target .NET Framework as well. Then you got .NET Core. If you're on 2, you get 7.3 as well. If you're on .NET Core 3.x, you get C# 8. And if you're on .NET Standard 2.1, which is the same thing as .NET Core 3x, you get C# 8. And if you go for the latest and greatest, and you go for .NET 5, which if you're building anything new, I think you should, you actually get C# 9, which is really, really cool. So there's a bunch of cool features in C# 9 that you might want to use. But what if you're on a platform or a framework that doesn't have the version that you want to target? Say that there's something in C# 8 that you want to target, but you're on .NET Framework. Well, the thing is, you can actually go into your CS project file, and then you just go in and in your property group at the top, you just add in lang version, and either you go preview latest major, or you go over a specific version, and then that turns on C# of that version in your project. and it's instead of using the default, which allows you to upgrade older projects to use new C# features. But keep in mind that some of the features that you have in C# is dependent on runtime features in your framework. So even if you take your old .NET Framework 4.8 project and you change the language version to C#9, you can't actually use all of the C#9 features because some stuff will be missing. But at least you can upgrade and you can use some of the features, and then the compiler will tell you when you're doing it wrong. So that's a nice way for you to take older projects and make them new again. I got a question here. Did record types make it to your list? Yes, it did. You will see record types at the end. Okay, so let's skip that. That was all just the stuff ahead of time. It's like you need to know this. Let's go ahead. Let's go and have a look at the top 10 best new features in C# version 6 to 9 according to me. And number one, and before I get started, this is not important, but it might be good to know. There is no particular order in the 10 items. I've just thrown them in there. Some things end up early in the list because I need to use those features later on in my list, so they kind of need to be introduced before I use them. Other than that, there's nothing that says number 1 is cooler than number 10. So number 10 is string interpolation. I'm a massive fan of this thing. I know it's nothing cool at all, but string interpolation helps us with this. So I assume that most of us have written a gazillion little string concatenations like this. We try to make a little message, and it's just concatenating strings with strings with strings, and it becomes this hard to read, messed up gumble, and it's performance-wise not perfect. So depending on how many things you concatenate, you should be using a string builder. String builders make it even harder to read. So yeah, not fantastic. And then some people will come and say, hey, you can use string.format. String.format is fine. It makes it a little bit easier because you get your format, and then you got your positional numbers, so 0, 1, 2, 3, and then you add arguments in and it concatenates it for you, which is really nice. There is one little thing about this, because you start using this, and I've used this a lot, it's very useful, and then you got I have words for these people, I'm just not going to use those because this is being recorded. If you get somebody doing that, all of a sudden they start moving around 1, 2, 0, 3, and then you have to go and look at, okay, so 1 actually points to first name, and 2 points to last name, and 0 points to group name. It's really, really not that easy to read. So if you are going to use string.format, please go ahead and use that. Not this whole, hey, I need to figure out and have a little PhD in string concatenation to figure out what's actually going to come out of this. However, with C#6, they introduced this idea of string interpolation, which is really neat. Because instead of doing what we just did, we can go ahead and write that. And honestly, it's just syntactical sugar. So in the end, that gets compiled down to a string.format and all of that, but they sort it out. But it's much, much easier to read this, right? So we put a $sign at the beginning before our double quotes. And then we go and we use curly braces to say, I want to insert the user's first name here, the user's last name here, then the string posted in, and then the group's name, and then the post date day of week, which is a lot easier to read in my mind. So number 10 on my list would definitely be string interpolation. It's one of those things I use all the time when doing my software development. Number 9, default interface methods. This was kind of a tricky one to put on my list. I kind of like the feature. It's really, really cool. But I honestly don't use it that much because in most situations, we solve it in different ways, in old school ways. But it's this. You go and write this interface, right? EmalClient. EmalClient has a send mail function, takes an address from, an address to, a subject, and a body. That's about it. Very, very simple EmalClient. And then in some meeting, somebody goes and says, shouldn't we use templates for the emails? And Yeah, we probably should, but you know what that means. So you get this fantastic feeling of, couldn't you just have not said that? Because your little comment now ends up with me having to write that. So I take my interface and I add this send templated email. Once again, it's got a from, a to, but in this case, it has an email template and then values to replace in that template. Okay, not a big problem. The problem is that once you change your interface with this, then Visual Studio will go and say that. So basically, it will say, oh, dude, there's already an implementation here, and now that you have changed the interface, my implementation doesn't implement that. Okay. That is fine if EmalClient, the implementation, is code that I own. Well, probably it's going to be because I own the interface, but it could be something else. And then it starts getting complicated. And also, if you have several different clients, then you have to go in and make changes to all of them. But with C#8, there's this really cool feature where when we define an interface, we can also add a default implementation. So in this case here, I add that send templated email method to my interface, but instead of doing what we normally do with an interface, just end it with semicolon, I actually do curly brace, and add an implementation. So this implementation has access to all of the other functions in that interface. So it can only use public methods of the existing interface because we know that once this gets added to the EmalClient, the implementing version will already have those things implemented for us. So by adding this, we can go and say, hey, I'm going to take this new version and I'm going to go and say, if you don't have an implementation of it, then piggyback on this implementation that just goes and converts it into send email, which is really nice. So that means that if you don't implement it in your client, you get this function or this implementation. But if you do want to go and implement it in a custom way, then you get a different implementation, which is really, really cool. As I said, not something we use a lot, but it does offer up some really cool ideas and solves a bunch of problems when you do have to break your interfaces and add new stuff to it. Okay, so number 8, out variables. So out variables is not a big deal, and you've probably used them. You just probably haven't thought about it. But the idea is this. How many of you have not written this, right? We all write this. We all do try parse methods, and we all write this code here, and we all look at that thing and go, why do I need to write int value and declare that on top of it? It might not be a big deal for you, but for me, a person with OCD or CDO, which it should be because that's the right order of the letters, it annoys me. It annoys me a lot. So without variables in C#7, which is where it was launched, we can actually go ahead and change it to that, which I personally love. It just means that we don't have to have that integer value declared before we do the try parse. Instead, we declare it as part of the try parse, as a part of the out, and then when after that line, after that if statement, that variable is defined and we can use it both inside the if statement and after the if statement, which is really nice. And also, to make it even better, we can go and say out var, so we don't have to care about the type, which I really like. I use var everywhere. I never statically type anything when I declare my variables. I always use var for everything I can because it makes it easier. So without var, it just becomes really, really simple to write instead of having to have that int value set on top of it. Not a big deal, but one of those features that it's tiny, but it makes my code so much better. Number 7. I'm going through this pretty fast. Expression-bodied members. So expression-bodied members are also not a big deal, but they make our code a lot more precise. It's the only way I can put it. So if you imagine writing this code here, and I've written a million of these properties. It's a get only property, or there are two of them, one string, one decimal. And it's not a big deal, but it is quite tedious. And honestly, it ends up with copy paste, right? You write one and then you do copy paste a gazillion times for however many you need, or you go up to the constructor and you go control dot and then create property and it sorts it out for you. But that's one thing. And it's not a big deal, but every single property takes up 4 lines of code. Sure. And also, by the way, we have that backing field, so we got 2 variables at the top as well. And sure, we could replace this implementation with this, which is the same thing. It's a little bit neater because we don't have a return statement. We just have get and private set. We don't need the backing field. Way better, but it's still 5 lines of code for every single property. And all we want to do is have a very simple return statement. So in C#6, they changed this and allowed us to do this instead, which is, once again, not a huge deal, but it makes properties a one-liner. You go public string name equals greater than, and then the variable or the member or field that you want to return. Nice, short, and syntactically still quite easy to read. Problem with this is that it's nice for read-only things. C#6 still required us to do this whenever we had a get set. We could go and say get colon, semicolon, set, semicolon as well and skip the backing field, but it still required us to do the get set. And in C#7, so it's just the next version of C#, they decided that, hey, we should introduce expression bodied gets and sets as well. So not sure I use that part a lot. I find it more useful for the get only, because the reason for having get set is often that in your set you want to have some code that validates the value or something like that, and this doesn't actually allow you to do it. So not a massive thing, but the get version of it is actually quite nice. And then we have these annoying micro functions, right? We very often have these little functions that just return a little thing. Get X or do Y. They don't do a whole lot, but they need to be there. So for example, toString. toString is generally, in 99.99% of the cases, implemented with just a return and a string interpolation, right? Because that's what we do. Once again, in C#6, they allowed us to change that into an expression bodied member. So it becomes shorter, simpler, there are no more curly braces, and still easy to read, right? And when we got to C#7, they made another update, which is you can actually do expression bodied members for your constructor and your destructor as well. Once again, not sure that these are a big deal. It would be cool to see if anybody in the chat can say, yes, I'm using expression body members for my constructor or destructor, because I think the usage is going to be tiny, but at least it's there. So now you know. Okay, so that was number 7. As I said, we're going through them quite fast, but it's giving you an idea of what's there, and hopefully or potentially you have actually looked and tried out most of these features already. This number 6 is discards. I'm kind of torn when it comes to discards, because a part of having discards is just a intentional kind of showing my intent, and some of it is actually quite useful. So if we look at discards here, or discard use in this case here, so I've got one method that awaits another method that returns a value. If I saw this, I would look at that line of code and sort of go, did somebody forget the return here? Or was it intentional? Or was the return value added later on and this code just haven't been updated? Of course, I have a very simplistic piece of code here. I've got 2 methods. They're really dumb. Do something and do something else. But you can imagine this being a more complex piece of code, and somebody awaits something that actually returns a value, and you just ignore it. It's kind of hard to figure out. So in C#7, they introduced this idea of a discard. So discard is just the underscore sign. So in the underscore sign, it's more of a explicit. So here, the underscore sign or the discard is saying, I know that there's a value coming back, but I don't care. This is intentional. This is the right thing to do. I know what I'm doing. The return is. So once again, not a big deal. Doesn't make any difference to the code. It doesn't change the IL that you get out there. But for the developer that comes along a month later and looks at this code, he or she can go and say, okay, intentionally didn't care about the return value here, which is good. I'll come back to the question in the chat at the end, so I can carry on here. Sorry about that. Take this piece of code here. So this is even trickier because this time do something does not await the other method. Imagine that this is like a logging function or something that it's not critical and it can be done asynchronously. So I'm just going to call do something else and let it run in the background. I'm not going to await it. I'm just going to keep going. This happens, but for obvious reasons, the Roslyn analyzer comes out and says, hey, wait a minute, this thing is not awaited, so you should probably consider using the await thing here. And it adds little green squiggly lines to your line of code. Kind of annoying. But if you go in here and say, discard the return here, the analyzer goes and says, okay, you know what you're doing. I'm not going to complain anymore. You're more than welcome to do that. You have intentionally ignored the fact that this is an asynchronous operation. So this is not just a matter of telling the developer that comes after you. This is about telling the compiler that I know what I'm doing. I do not want to await this thing here. If it doesn't work, then fine, I don't care. We've also got a really cool new thing in here, which is a combination of discards and throw expressions. So this is pretty common code, right? You go in, this will not compile because you didn't pass any argument. Oh, sorry, true. I forgot an argument here. I don't think you guys realize how hard it is to code in PowerPoint. I have literally sat down and color-coded every single word of my code to make it more readable, so it actually has the same color coding that I have in my Visual Studio. But everything is manually color-coded, so yes, if I miss something in code, please point it out so I can fix it. I've forgotten a string here, I agree. Okay, so coming back to my check here. This is very common code, right? You get a string value passed in, and then the first thing you want to do is you check if the string is null. And then if it's null, you throw an argument null exception. And then you check the length of the string, and if it's less, that's an incorrect one as well. If length equals 0 should be, not greater than, damn, my code is bad. Now you know why I do presentations and don't code, right? If the length is 0, then I pass in I throw an argument exception. This piece of code is fine when there's like one parameter coming in, but if you have multiple parameters coming in and you need to check every one of them, you end up with n times 2 little if statements to figure out if they're okay or not. This is really cool. So this combines some null-coalescing stuff together with the fact that throw has now turned into what is called a throw expression in C#7. So we can do a discard here saying that assign whatever, I don't really care. If the name, assign whatever, I don't care, to name, or if the name is null, then throw a new argument null exception. So instead of having 3 lines of code with if statement, we can do this very short syntax here. And due to the fact that we are assigning the response to a discard, it just gets discarded, but it means that it throws an exception if the name property is null. And on the second one, once again, the check is wrong here. It should be equal to 0. It checks to see if it's equal to 0, then I don't care. But if it's not, then No, sorry, in this case it's right. If it's larger than 0, then it's fine. If it's not larger than 0, then throw an argument exception. So we end up taking this here, which is 7 lines of code, and we turn it into this little thing here, which is just 2 succinct little rows of code that everybody can understand, hopefully. So that's a very big favorite. I use this in pretty much everything that I'm writing today. Whenever I see that old if statement, I kind of feel sick and I have to change it. So I have a lot of little commits to different projects where I've just changed these things because this is so much easier to read. So that brings us to number 5, which I've already kind of touched, and that's null-conditional operation and null-coalescing assignment. So we're going to start out, I'm bringing them into one, just calling them number 5. I know they're 2 different things, but they are very closely related. So I'm going to start out with looking at null-conditional operator. So here's another one of these checks with null checks and everything. And null is a pain in the butt to work with, to be perfectly honest. So here is some code, and it goes and says, if order is not null, if order recipient is not null, if order recipient email address is not null, then send an email. Chunky piece of code, not hard to read, it's just very long to read and very verbose. And yes, we can change it into this, so we can get ands in there. We only have 1 if statements, but there's still a lot of stuff to read, right? In C#6, they changed this and allow us to do this. So they introduced the null-conditional operator, saying that if order is not null, then look at recipient. If recipient is not null, then look at email address. If email address is not null, then return email address. If any of these values along the way is null, then it returns null. So it's pretty cool. It makes that line of code a lot shorter, which I really, really like, and it simplifies a lot of things in here. I have a a few comments in the chat here. With nullable reference type, most guards are gone. Quiet! I'm going to come to nullable. Just wait a little while. I promise you, it will be in there. So that was your null-conditional operator. It's just useful. I keep forgetting it in C#. I use it all the time in TypeScript, in Angular stuff that I'm building. But for C#, I still do a lot of the old stuff, and that's kind of, it's fine doing the old things as well. You can keep that in mind. So the other thing is the null-coalescing assignment. Once again, a tiny little feature, doesn't do a whole lot, but I really, really, really love it when I can use it, because look at this piece of code here. Very, very common code in my world. Not very, very, but it's pretty common. Where we go and say, if you passed in null, then, hey, I want to replace it with my default value. Yes, I could go ahead and add a default in the method up there, but this was a simplified version of what I wanted to show. And in this case, we can change this and say, as of C#8, by the way, we can say this, question mark equals. So that means that take options, assign the options variable to either options, or if it is null, assign it to my options.default instead. So it just shortens down that if null options equals blah, blah, blah into question mark equals. And my honest opinion, are we getting to the point where C# needs 3 character operators? It's getting a little bit out of hand in my mind. I have a hard time remembering all these operators, and honestly, if they start adding in 4, I'm gonna leave and start doing JavaScript. But it's pretty cool. This thing can help out and make your code, once again, just shorter and simpler to read. And that's a reoccurring thing that you end up with when it comes to C# features coming up. And that's the fact that everything gets shorter, more concise, but still hopefully quite readable. Got more comments down here. I'm going to look at the chat afterwards. Sorry, I'm going to keep going. So number 4. Already mentioned nullable reference types. I really, really love the idea of nullable reference types because, as mentioned in the chat already, that it solves a bunch of problems. So imagine this piece of code here. once again, we're back to nullable checks. And yes, we've made nullable checks easier with the discards and the null operators and things like that, but we still have to go in and check values for null, which is kind of annoying because by default in C# or sorry, in .NET, reference types are nullable, so anything that is a reference type can be null. And that means that you have to keep track of what's a value type and what's a reference type, which is not hard if you're a developer since a long time back. But if you're new to the language, it can be a bit confusing and hard to read and hard to figure out when it's possible to be null, when it's not, and so on. In C#8, they introduced this really cool feature called nullable reference types, where we can say that a reference type it has to be specifically null. So that means that we can remove the null check to our print length and just leave it at this, because with nullable reference types, we know that this string is not going to be null because it's not null. It's a reference type and they can't be null because I turned that on, or that's a feature of C#8. And then you go ahead and you write some code like this, which is fine. And then somewhere in here in that ... where all the other code is, you do not assign the string here to anything. And then it turns out to be null. And then you run the code and you get this. System.nullReferenceException string, but Chris, you said that if you had C#8, then it was nullable reference types, and my reference type couldn't be null, so you're screwing with me. I'm not. It is true that with C#8, you've got nullable reference types, but for backwards compatibility, they are not turned on. So nullable reference types is not something you're going to get just because you upgrade to C#8. You actually have to go into your CS_proj file and you have to go and add this nullable and set it to enable to turn on nullable reference types. And if you're on older versions of .NET and .NET Framework, for example, or .NET Framework, you have to go in and set the language version to 8 because .NET Framework defaults to 7.3. And then you have to turn on nullable as well in here with enable to get nullable reference types turned on. And also, important thing to remember here, nullable reference types is not a change to the runtime. It's not something that actually exists in the runtime as such. The runtime has no clue about non-nullable reference types. They're all nullable. What we get from turning this on is that the compiler will go through all of your code and figure out where you're potentially passing in a null value where you're not allowed to pass in a null value. So it's a compile time check, not a runtime thing. So that's why we can turn it on in older versions as well. And then we don't have to make any changes here. And we don't have to make any changes here. But all of a sudden, because I turned on nullable, this string value here will be a string. It will not be null. And as I said, no change in here either. The only thing that really happens when you run this, when you turn on nullable, is that Visual Studio has a Rossnil analyzer or analyzer in here. The compiler looks at it and goes, possible null reference argument for parameter value, blah, blah, blah. That's it. Nothing else happens. That's what's happening. But it makes it possible for you to look at the warnings and go and say, oh, wait a minute, I'm doing something that could go wrong here. And if you explicitly do want to have a nullable reference type, you have to literally make it nullable. So you have to go in and add a question mark after string to say that I'm going to accept something that can be null as well, and I will take responsibility for checking to see if the value is null or not. So that little thing there says that I know it can be null in here, but I know what I'm doing. And then you can use these null-conditional things to figure out, to maybe do a default value or something like that instead as well. So the null stuff can still work and still be useful. And here's another little sweet thing. Once in a while, I'm not saying that this is often, I couldn't actually come up with an example straight up that was easy to show, but you can come into situations where the compiler cannot figure out that in your code somewhere before this write line statement, that value gets assigned. So you know when you get to this point that it is not null, but the compiler will still complain. And what you can do then is you can add an exclamation mark telling the compiler that I know it's nullable. You're telling me that it could be null here, but I know from my code, which is apparently too complex for you to figure out, that it has a value here. So stop complaining. I know what I'm doing. I love the fact that we now have a bunch of little extra things in our code, which is us telling the compiler that I know stuff better than you do, but that's the way it works. But this is an interesting part, coming back to the warning here. So the only thing that happens when you do something wrong is that it becomes a warning. Nullability issues in nullable reference types are just warnings. They do not turn on any errors. They do not cause compiles to fail. They will just go and say, hey, you might want to change this. So if you do want to turn it on and make it a warning, or sorry, an error, and actually have stuff fail when you do it wrong, you go into your CS proj file and you set warnings as errors nullable. That will turn all of your nullable warnings, which is a bunch of CS86002 something, into errors and actually fail your builds. So this will keep your developers on their toes and making sure that they actually do take care of the nullability. And then all of a sudden, those things turn into errors instead. So my exactly the same error message, the CS8604, turns into be an error, not a warning, failing my build, which is really cool. If you start doing this on older code that's already written, you might want to look at this little pragma thing here, compile statement, that basically says, nullable enable and disable and nullable restore, because this allows you to turn off nullability for a part of your code. So if you turn it on for an old code base, for example, and you don't have time to go through it, all of it, you can go and put in nullable disable and remove nullability checks, and then nullable restore to go back to the default after when you're done, or you can explicitly enable it for certain areas and then restore it back to disable once you're done with it. So being able to turn it on and off in your code is actually quite useful for those scenarios, because it's cool to turn it on in an older code base, but it's also problematic because if you turn it on in anything larger than a Hello World app, you're going to end up with a gazillion different warning messages in your compiler. Okay, so that brings us to number 3, which are named tuples. So in a real world scenario where you had been in the room, I would have liked to see how many of you had actually written a piece of code like this. A stupid return value class that is only written for you to be able to return 2 values from a method. So say that you have an HTTP client that needs to return if it's successful or not, and it needs to return the response as well, so that I can check is successful and then look at the response afterwards. Really annoying little class. It needs to be there because C# doesn't allow me to do multiple return statements or return multiple values. I can use out statements, out values or out variables, solve this problem a little bit. However, you cannot use out variables or out parameters for asynchronous methods. So if you're doing async, you're going to end up having to do this, right? C#4, so Chris, you said you were going to talk about C#6 to 9, and now you're talking about C#4, which is probably 20 years old by now. Yes, I just want to show you that C#4 introduced what's called C# tuples, which is this thing here. We can create our methods, and then we can say, I want to return 2 values. I want to return what's called a tuple, which is an object with more than 1 value. And then we return, in this case, a Boolean and a string, and I can return true, and it worked, which is fine. So that solves a problem. And I really, really, really tried to love C# tuples. I tried to use them. And every single time I've used them, I have come back and said, I'm not going to use them. And I've thrown them out because I couldn't use them, because it looks like that when you start using them. So you call do something, you get an object back, which is a tuple. But that tuple has an item 1 and item 2. No explanation what they are. No explanation what they contain. No idea. Yeah, it's a Boolean and a string. No idea. Especially if you start returning multiple strings, for example, and you go, wait a minute, was it item 1 or item 2 or item 4 I should be using in this case here? It's just, yeah, not that great, not a big fan, but they are there. And that is called a C# tuple. C# 7 introduced a new type called a value tuple. So a value tuple is a little bit different, and you can use these in .NET Framework as well. And if you're below 4.7, you need to add a NuGet package. So it's actually something you can backport quite a bit. But it allows us to use a syntax like this instead. So we name the Boolean and we name the string. In this case, is success and response. We return it in exactly the same way, but when we come to use it, we get an object that has an is success and a response method. A response property, which is really, really awesome because it's so much easier to use, and it makes much more sense. So the reason I went back and looked at C# tuples versus value tuples is that I want to show you that I know that we've had tuples for ages, but they are very, very different. So C# tuples are immutable reference types with properties. So they're small classes. Basically, they are classes and they have properties and they are get set properties, so they're mutable. Whereas value tuples is a value type and it has fields instead. So it's actually mutable. When you get a value tuple back, you can change it however much you want. There's no immutable value tuple. So you have to choose between immutability and item 1, 2, 3, 4, 5, or value tuples, which is mutable but have field names that are actually usable. They also support destruction or deconstruction. Deconstruction is a new feature in C# as well that allows you to work with not only tuples. This can be done with real classes or other classes as well by implementing a deconstruct method. But what we get here is do something returns a tuple with 2 values, but I split those 2 values into 2 separate variables. So I have a bool is success and a string response, and I take the tuple, I split it into these 2 properties, and then I can use them individually. So that part there is called deconstruction. And then we're back to that stupid out thing again, where I have to declare my parameters or my variables before I use them, which is kind of annoying, which they know at the C# team. So they introduced this syntax, which is nice, where you can inline the declaration of the variables, so you don't need to predefine them before you get started. And then they took that one step further and they allowed us to do that. So you add var and then it figures out the types based on the tuple you get back automatically. So you just go var parentheses is success response, it figures out the types, and then you can start using the things afterwards. And then you can combine that with discards, where you basically say, I care about this success one. I really don't care about that other thing. So the string that you're returning, don't care. Only care about whether or not it was a success. I can then go and say, hey, discard this. I don't need a variable for it. Don't care, which is quite nice. And then in 7.3, they added some more features to value tuples, which, for example, they added equality comparison, which is quite nice. So if you declare two value tuples like this, they are 2 values, but they have equality comparison built in. So they verify the X and Y in this case. And if they're similar, the same thing, they come back as true. There is a little caveat with using this, because if you look at this code, this is kind of complicated. Yeah. So X and order in this case are equal. It doesn't care what your property names are. It cares about the positional thing. So it looks at the value tuples and go, the int32 at position 1 on X equals int32 at position 1 on order. And the same thing for the string at position 2. So you can name your properties whatever you want, but when you do value comparison or equality comparison, it will just look at the positional things and check to see if the position is the right type, and then if the value is correct, not what that position is named, which can be a bit of an interesting situation if you start using it a lot. So that was value tuples. Next thing is a big one, pattern matching and switch expressions. So pattern matching and switch expressions are two different things. I know I'm cheating and bringing in more than 10 things, but they are very closely connected. So imagine this piece of code here. I don't recommend writing this piece of code. Coming up with really good examples that fit on one slide is really hard, so I made a really dumb one. But imagine this thing here. I have a log method that takes an object, making it possible to log anything. First thing I do is check to see if it's null, and then I return, because I can't do anything with null. Then I check to see if it's a string. If it's a string, I cast the string to a string, and then I check to see if it's empty. If it's not, then I write out the string. And then I have this thing here that checks to see if item is loggable, iLoggable. And if it implements iLoggable, I cast it to that interface, then I check it, do a switch over the log level, and depending on the log level, I write out different things to the console. And finally, if it's not a string, it is not null, and it's not iLoggable, I write out unknown, and I do a toString on that object and write it out so that I can find it in my logs afterwards. Probably not the best implementation of a logger, I don't care, it's a demo. So if you have any comments about that, keep it out of the chat. C#7 made this easier. First of all, they made it possible to write this, which I really, really like. If you look at the if statements and the else if here, you can do item is string and then add a variable afterwards, and the compiler will automatically check to see if it is a string. It will also convert the item to a string and assign it to that variable, so we don't need to do a manual cast. Okay, that makes it a little bit shorter, but it's still pretty hefty. Then they introduced pattern matching. It's basically a more advanced form of a switch statement, where we can start out by looking at is the thing that we're matching, is it a specific value? Is it null or is it empty string? In that case, return. If it's a string, please assign it to the variable str, and then I can do a console write line str. If it's an iLoggable and the loggable level that you have given me, so basically take it iLoggable, and if it is, assign it to the loggable variable, then check the loggable variable to look at the log level, and then figure out based on the log level, do something specific. And finally, if it's not log level error or warn, then just use the loggable and write out the message, and default at the end, hey, write unknown. So that long if, else, if, blah, 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 turns into this a lot more readable statement here. On top of that, it allows us to do this. Yay! We get to do is null instead of equals null. I don't know if it's a big deal, but it looks nicer. C#8 took it a bit further and introduced this really cool switch statement here. So it's a pattern matching switch. So I do an expression bodied member called getErrorMessage, and then I do item switch instead of switch item. And then it looks at the object, it does a switch again, and each one of these values have to return the same type. So in this case, getErrorMessage returns string. So if it's null, return string. If it's empty string, return empty string. If it's string, return the string. If it's an iLoggable of these levels, return this string here. If it's just a loggable, return this. And if it's anything else, which is the discard one, we come back to discards quite a lot here, we just return unknown and the item. So this gives us a really short, nice syntax. When we know that the return type, we can just do this nice switch and the pattern match in here and get short, very concise code of what we're doing. And if you look at this, where we actually know what the type is, so we know it's an iLoggable, we can actually go ahead and say this syntax here, which is curly brace, and then the property that we want to check, and to see if it's a specific level, and then do it based on that. So that makes it, we could have done if I pattern matched it to loggable and then when and all of it, but this is just a shorter, nicer way of going, if this property is this, do that. Also, don't forget this. There's nothing that stops you from passing in two properties to this error message here. you still only get to switch it on one. So you can only switch on this item here, but you can still use both area and item in this case. So it's fine to take in more than one parameter, but you can only switch on one thing. However, if you want to switch on multiple things, you can actually take multiple parameters in, and then you turn them into a tuple, and then you switch on the tuple. So basically, this thing here matches both of my values, which allows me to make a really, really concise rock, paper, scissors. I don't know if that's useful, but being able to pattern match on a tuple is actually quite nice because it allows us to pattern match on two different objects. And also, discard is everything else. C#9 takes it a bit further. C#9 introduces this. There's a lot of code in here. So if we look at the important part, it's basically just is valid file name. This first part here takes the file name, goes all, uses link to go through every single one of the characters, and then it uses x is, and then it allows us to do greater than or equal to a and less than and equal to z, parentheses or, so we can combine ands and ors to make this would have turned into a pretty hairy if statement, to be perfectly honest. Turns into a pretty concise one-liner that says, hey, if it's lowercase a to z or uppercase a to z or dash or dot, then this is fine. Yes, I could have done a static or a constant string with those values in it and gone that it contains it, but it's like this now. And for the extension, once again, I can pull out the length, and then I can say if the length is less than or equal, greater than or equal to, or less than or equal to, which means I don't have to do two ifs. Like if length is that and length is that, I can do both ends of the if in one statement. And you can do x is not null, which is so much more readable than x exclamation mark equals null. I don't know why I'm happy about that, but I am. And the last one, the number one thing that I've got, once again, not in any particular order, but it's record types. And I got a question about record types before, and yes, it's here. And it's easy to come up with this, like, wait, record types, is there going to be another type? Because we've already got value types and reference types. Are we getting another type of objects? And no, we're not. We are not getting another type of records or type of objects. It is still the same thing. Records are immutable reference types with the default implementations of minimal code, default implementations generated with minimal code. So basically, we get default implementation of some things in our code for free, and we have to write minimal amount of code to get it done. So imagine this piece of code here. It's an immutable order class. Not a big deal, but it's if we look at this code, we go, that's boilerplate, and that's boilerplate, and that's boilerplate, and that's boilerplate. So a lot of this is just stuff because I need to have an immutable object or data structure that can keep this value here. And if you take that boilerplate, and then we're going to say, hey, I want to have equality checking as well. So can you please go ahead and add equals, get hash code equals equal, override equals, not equals, toString? That's a lot of code. You look at that and you go, oh, that is a lot of code. I don't want to write that, but we keep on writing that if we want to have immutable objects. So in C#9, all of that code, all of that constructor, property assignment, toString, operator overloads and everything is turned into that. It's everything. Public record order, property names, types, and it generates it for us. This gets turned into an immutable class. There's nothing magical in here. It gets turned into an immutable C# class with properties called ID, article name, and total. They are read-only, and it overrides the toString method, and it overrides equality checking with get hash code equals and so on. So when we go and say new order, we can go and we can check out whether or not they're equal. And as long as all the values are the same, they return equal. But even though they're not reference equals. So they're two different references, but they are equal because equality has been overridden. And if you do console write line, it does a toString and it outputs a default implementation of toString. not the best two-string implementation, but it's a two-string operation, and all the other stuff with get hash code and everything is taken care of. That is just really awesome. They also introduced this cool little thing here. So we've got this with syntax. With allows us to take an immutable thing and turn it into something else. So basically order one here. And then I take the immutable order one. I want to have a copy of that, but please replace the article name with test2. I get a new immutable instance with the article name changed to test2. And in the case of order 3, I'm just doing a perfect copy of the existing thing. But with allows us to basically take an immutable thing, generate a new immutable thing with something changed. It allows us to do inheritance. So we get to do our own constructor, and it still works. It figures out all the properties for us. We can even add methods to it. That's fine. So we can do all of the things we do with the class normally, but we get all of it in a much smaller package. There's not too much in there. So record types are really, really cool. So that was about it. That was all the 10 features. However, once again, they are my favorite features. There are other C# features. There's a whole heap of them. I've got a list of all of them. Some of them are really cool. Some didn't make it. Some made it. These are mine. But it brings an interesting question when I had this talk, and it's funnily enough, I'm an ASP.NET, .NET MVP, and on the MVP email alias, somebody came in and basically asked this question: is C# getting too complicated? Lots of really interesting comments about it, lots of discussion. And I had the same question before this talk, and actually I still kind of have the question, but I think a lot of the answers on that email thread was interesting, and I think the conclusion is C# is not really getting too complicated because we're not removing any features, right? We're only adding new syntactical little things mostly to it. And if you're new to the language, you probably go and you just learn the new stuff because you might not need the old versions of it. And if you're used to the old versions still work, right? There's nothing that forces you to use the newest features. So is C# getting too complicated? Yes, there's a lot of stuff in there that C# offers us that allows us to build cool things and write really precise code, but there's also the ability of writing everything like we did before. So I'm not sure. There's a lot of features in there. I know that the C# team is spending a lot of time figuring out what features should be in there and not. I think a lot of the stuff, as I said, these are my top 10 favorite ones. There's still some stuff that I find might be not too useful, but there are scenarios where it is really useful. So is it getting too complicated? Don't think so. And with that comment, it's not getting too complicated, I want to thank you all for listening. I'm going to go and say, I'm going to look through the chat and see if there are any questions. If you don't want to hear the answers to the questions, you're more than welcome to go. I just want to thank you all for listening. I hope you got something out of it. If you have any questions, as I said, the chat is fine. You can also find me on Twitter if you want to ask any questions. That's the easiest place to find me. More than happy to answer any questions that you have. And if I scroll back down through the chat here, there's not a whole lot. There's nothing on Slack, which is nice because that's really hard to read on my iPad. Question mark dot can be useful. It is also very useful, easy to abuse it. Yeah, so yes, with the question mark dot, with the null operation, null conditional stuff, it is easy to just add it in there for the heck of it. I think a lot of that kind of disappears once we start doing nullable reference types. So hopefully we'll get a nice sort of mix of useful and not so useful. And then, oh yeah, so there's the comment about the nullable stuff, conditional nullables, defaulting to string. And why are you defaulting to strings? Question mark. Someone has no answer, just using feature. Yeah, don't look too much at my code. It's really, as I said, really hard to write good examples that fit on one slide in large fonts and still are good enough for you to absorb it or rather show the feature that I want to show. So don't look too much at why I'm doing stuff. In a method where the first line source argument null except if order is null. Not sure what that was about. X is null is a big deal because it means that even if the class has an overridden equality comparer, it ignores that and just checks if null equals null. Okay, that's a good comment. I've actually thought about that. So X is null is a big deal because if somebody overrides equals and does some funky stuff with null, then is null will actually not go and look at the equals operator. It will just basically say it's null, I'm not going to go any further. Difference to that is that when you do object equals null, then it goes and looks at the operator, and if the operator does some funky stuff with null, then it might not return what you believe it returns. Having that said, that person on my team that overrides equals and does funky stuff with null will not be in my team for very long, I'm sorry to say. And if you are in my team now, I'm sorry for saying that, but that's just the way it is. I don't think any in my team is actually in the chat, which is good. Record types best used in... Yeah, so use cases for record types is interesting. I think they're going to be a big deal when it comes to DTOs. So API responses, for example, responses from your API, which needs to be basically just simple classes, having that very terse syntax of getting something generated for you by just adding a one-liner. I think that's going to be awesome for example, DTOs. Also, if you need anything that needs to be immutable, if you're doing a lot of immutable coding, then I think record types is going to be a very big deal because it helps out with that paradigm of doing immutable code without having to spend a gazillion hours writing classes with just get properties. You have to be able to read other people's code is a comment here. I guess that comment is about all the new C# features. I agree. With new C# features, you can get away with using new things or old things when you're the person developing it. When it comes to reading somebody else's code, yeah, in that case, it becomes a matter of, does the person understand? If I use the latest and greatest syntax, will they understand that? If I use older versions of stuff, will a new developer understand that? I get that point, and that's a very valid point. And honestly, I do run into syntax stuff in C# once in a while with my colleagues that I actually have to look up. And I learned a lot from it. And I think that is hopefully what's going to end up. If you read code that you don't understand, you're going to ask the person who wrote it and go, wait, what's happening here? I don't quite get it. And they will say, well, it works like this. And then you've learned something new, and then you'll start using it yourself. One of the things being like the discard throw statement, where I can do very short syntax for checking things and throw an exception if something is wrong, is one of those things I've learned along the way that somebody showed me, and I'm like, oh my God, that changes my life for the future, which is cool. So then there was some comment about properties may not want to include in the quality. If you do want to change the equality comparison on in your record, you can go and override everything. It's just a C# class. So if you want to change the equality, that's fine as well. If I can upload the slide deck to GitHub, yes, I can probably do that. I don't know if Jacob, are you around? I don't know if there's not a so Jacob seems to be around. Do you send out the slide decks or store the slide decks for NDC somewhere, or should I put it on my GitHub?
Just you can share them in Slack.
Okay, that's a good idea. I'll put it in Slack so you can get the slide deck if you want to have it. Thank you, Jacob. a sample class where you do all the features in one and compare. Yeah, I'm not going to do a sample. Well, actually, I might do one in the future to put all the features in one place, but yeah. By adding new lang into a client in, for example, .NET Standard 2.0 and add that to a .NET framework which has not updated lang, what will that occur? So the question is, if I change the language version for a .NET Standard thing and you start using that in a version that doesn't have that language feature, will that be a problem? No. Because anything that you put into another language version that requires something from your framework will not work in .NET 2.0 unless it's covered by the framework that is going to be used in. So if you do something in Standard 2.0, the C# language will only allow you to do features that is supported by all the frameworks that support 2.0, I think. So you won't be able to use, for example, records because it won't be there. So I think it's pretty safe for you to update the language version. There might be edge cases and somebody on the C# team might come out and say, Chris, you're wrong. But I do believe that you're quite safe because the .NET Standard version should keep you in line what you're allowed to do, because most of this is just compiler tricks and syntactical sugar. That was all the questions I could see in the chat. Once again, I hope you enjoyed the talk and you got something out of it. If not, sorry. If you have any more questions, Twitter is fine. I'll see if I can get the slides uploaded to Slack so you can get it. And other than that, thank you so much for listening.